Hello everyone, this is a brief demo of the project Wordle Assistant for CS221. So the goal of this project is to build a reinforced learning based AI assistant for the game Wordle. If you don't know this game already, this is a very easy like word game where you can guess 5 letter words, and this word has to be a valid word in the dictionary, and the game will tell you if you get a correct word, a correct letter, um, based on the color of the letters. So if you get a green letter, it means that the letter is in the right position, and a yellow letter means you have the right letter but not in the correct spot. And the goal is to guess the word, guess the target word as quickly as possible, and you have only 6 guesses for each game. And I'm going to start my program right away. This is written in Python. So, yes. And on the other side, I have the infinite Wordle open. So usually on the official Wordle side, there's only one chance. There's only one problem per day, and for this demo, I'm going to play this game multiple times. So I have this infinite Wordle open here. I believe they used a similar word list, so it shouldn't be a big problem. So here's my Wordle assistant. So I'm going to type in help to see what it can do. First of all, I have 3 available agents listed here. I have a random agent, which basically just gives you a random word when you try to play the game. And the coverage agent is a heuristic based agent, which is not related to reinforcement learning, but it has a very great logic based like algorithm for you to make the next guess based on the occurrence of the current letters and the whole available solution list that is still possible at your current stage. And of course, we have this Q learning agent that can basically play, basically perform self play training. Okay, so after I switched to random agent, I will just quickly start a game here. It is suggesting a new word, so I'm just going to use that as my guess. That would be HARS, and I will hit enter because I used the suggestion directly, and um, give it back the feedback that I get from the game, and it will just randomly give another word. Usually the random agent will not win me the game, so I'm going to stop it right here and switch to the coverage agent, which is usually performing much better. So switch coverage. Yeah, so now I'm using the heuristic based agent instead. So let me just use this word again actually, and use the same feedback again. Okay, so it gives me the top candidates again, and based on the letter occurrences, now it's suggesting this new word, and I just use the word directly, and YBYBB. Okay, so now it's suggesting crown. This looks much better now. And okay, so now I have Corky, which is likely going to be already solving the problem. So y g y. Okay, so now I have the Rocky as a candidate, but since this still suggesting Corky, I still have this valid option. So I'm just going to use Rocky as my final guess, and it wins me the game. So this is just a heuristic based agent or solution, which is not that effective. Okay, now I'm going to switch to my Q-learning agent, and note that I have already trained the Q-learning agent because I have this checkpoint already saved, which is named final. So let's start with another game. And now it's suggesting alter. You can immediately know that it is suggesting some very good words with some common letters. So alter it is. I used your suggestion, and it will be Y with 4 blacks and Mason. Okay. BG. Cool. And bacon. Alright, so you can see that it is just guessing based on the green letters, and it's making pretty good and reasonable guesses. We have, okay, now we only have wagon as the last candidate, so it wins me the game, and it's faster than the coverage agent. So yeah, that would be a quick demonstration of what I have for playing the game. Let's finish this. So yeah, now we have solved this problem. Let's see what it can do for the learning purposes. So you can train your Q-learning agent in 2 ways. You can have a list of generated Wordle gameplay data, and it's in the form of a JSON, and you can train on like existing data. Maybe you can gather data from like the official game, and with millions of data, it might be working better than the self-play. But usually I just choose self-play because it will be hard to get um, such kind of large-scale data for training. So I can quickly demonstrate the training here. We already have an existing checkpoint, which is called final. We can, for this demo, I will just create a new checkpoint, and if we want to quickly train in this demo, I will just use like 100 for demonstration purposes. The rest of the stuff is just default values. Yeah, and you can see that it's doing the self-playing, and yeah, 100 episodes is quickly covered. So now we have a trained Q-learning model with a pretty high win rate, but I think this average tries for this checkpoint is lower than what I have here for the final one. So usually you want to train it with more episodes, but I won't spend time on that in this video. And the final thing I have to demonstrate is the evaluation function here. So in the help, we have eval with agent as the parameter. So let's quickly do a evaluation on the random agent, for example. It will simulate 200 games and print out all the metrics, including win rate, average tries for all the games, and average tries conditionally with like the win games only, the won games only. And for won games only, we have a guess distribution. Unfortunately, random agents is performing um, pretty badly. So yeah, those metrics are not looking too good, but we can do better with the other agents. So let's try coverage. Okay, so now it is giving me a win rate of around 40%, and average tries is 5. You can see that the guess distribution is from 3 to 6. It's pretty uneven. And let's finally test out the Q-learning agent with my final checkpoint. It is doing the same thing. Um, it might be a little bit slower than the rest of the agents. Okay, so yeah, you can see that it is um, winning almost every game, and average tries is much lower with a distribution of 3 and 4 being the most. Yeah, so that's pretty much it for the program, for the demonstration. I do have this software or project uploaded to GitHub, and it is publicly available. You can check it out when you are interested. And thanks for watching this video.